This video is about how the proper power of lens can be selected to correct the eye condition known as myopia and correct it to that of a normal eye. In this video, I will briefly discuss what myopia is as well as how an optometrist might select the proper lens by use of the thin lens formula. Now here is a picture of a normal eyeball looking at an object. You'll see from the green ball the light rays entering through the lens of the eye, through the eyeball itself, and then it sharply focuses perfectly at the back of the retina. And here is a myopic eyeball. You can see clearly from the first image that the eyeball is more elongated. So now the image is actually focusing some distance in front of the retina, thus making the image for the viewer appear as blurry. Here I will use laser beams to represent rays of light. There at the back of the retina is where the normal eye would see a focused image through the lens. And here we will change the lens to mimic the effects of a myopic eye. Next, I'll select a diverging lens, which is set at a particular power in order to correct the internal focal point of the eyeball to hit the retina so that the image may appear clear to the viewer. A normal eyeball is considered to have a far point of infinity, in that at the relaxed state it can see great distances very clearly, whereas with a myopic eyeball the far point is considerably less than infinity. Here I've chosen 20 centimeters. The far point being the furthest distance a myopic eye can clearly see. Now to choose the proper corrective lens, the power of lens must be determined, and it is used by finding the inverse of its focal length and then using the thin lens formula to determine this focal length. Here it's 1 over f equals 1 over p plus 1 over q, whereas p is the object distance, q would be the image distance. In this case, we will assume that the object distance is at an infinite distance, which would be a normal eye vision, and the far point equals 20 centimeters, or 0.2 meters. So doing the formula, 1 over f equals 1 over infinity, which of course is going to become 0, plus 1 over 0.2 meters, which gives us 5 diopters. Now I did make an error here. I did forget to include that because the image is virtual, that this distance would be considered negative as the image is on the same side as the lens as the object. Thank you for watching my video, and I hope that you learned a little bit more about how to select a proper lens to correct myopia.